Hi, I'm Xin Wang. My project is a PageRank on distributed system. As you all know, it's an information booming age, and we are surrounded by millions of information. But how can we search the information that we are interested in, and how can we sort or store the information? That becomes a hot research area. And one of the most popular algorithms for link analysis is a PageRank, which is mainly used by Google to design their search engine. And in order to improve the performance of the PageRank algorithm, in this project, I use a MapReduce model. So here are two main aspects of this project. First, a MapReduce model, and second, PageRank. MapReduce is a programming model and an associated implementation for processing and generating a large data size with a distributed algorithm on a cluster. A MapReduce program is composed of map procedures that performs filtering and sorting, and a reduce method that performs a summary operation. The MapReduce system orchestrates the processing by marshalling the distributed servers, running the various tasks in parallel, managing all communication and data transfer between the various parts of the system, and providing for redundancy and fault tolerance. Here is the MapReducer flow. First, the map step. Each worker node applies a map function to the local data and writes the output to the temporary storage. A master node ensures that only one copy of the redundant input data is processed. And here is shuffle step. A worker node redistributes the data based on the output keys, such that all data belonging to one key is located on a same worker node. Last step, reduce worker node and process each group of the output data per key in parallel. So I implement the MapReduce model as an example for word count. And the sample is, for example, it's an article, and my aim is to output the result, which consists of two parts. The first is the word, and second is the number of the word. And each line, the first part is a word, the second part is a number. So here is my code. The first step, the map step. The map step, I separate the article into a single word. And in the reduce step, I just put the same word together and count the number of each word. Okay, here's the second part, the PageRank. PageRank is a link analysis algorithm that assigns a numerical weighting to each element of a hyperlinked set of documents with the purpose of measuring its relative importance within a set. PageRank algorithm outputs a probability distribution used to represent the likelihood that a person randomly click a link will arrive at any particular page. PageRank can be calculated for a collection of documents of any size. So here is my sample. I download this sample graph, which each line stays with a node ID and its adjacency list. And this file is attached in my project. And I developed an iterative MapReduce program to implement PageRank, and I list the top 10 nodes in order of descending PageRank value. Here is the result, and also this file is attached in the file. And I'll also give the graph property, such as number of nodes, number of edges, and minimum and max and average of odd degree for each node. And also I list the total number of MapReduce iteration for convergence. And I use AWS to implement the program to figure out how distributed system proceeds to a task. And also I run the program on my own PC and compare their performance. For example, the total execution time for the first iterations, and I also draw the curve for time versus iterations. As we can see, the first 10 iterations, the AWS has the same performance as my own PC, but after that, if the iterations is more than 10 times, it's obviously that AWS have the better performance. It uses less time, as we can see in the curve. The execution time and the iteration is a linear relationship, as we can see. Okay, here is my project. Thank you.